All right, turned OBS on. Let's see if preview is on. 360p seems pretty low. Oh, 1200p. Let's check the volume. Oh, 1200p. All right, that seems good. I'm working again. I actually do want mute but play. Okay, perfect. And bitrate is solid and steady. Okay, so couple changes to how I'm streaming since yesterday when the stream cut out a few times, then I just couldn't get it back. I am no longer sending the stream out on the Linux computer. Now I am sending out on a Windows computer that's attached to this, and then that's actually hardwired into the Ethernet because I have the ports for it, unlike on this Linux notebook. But at the same time, I do have my chat over here on my Linux second screen, so it'll be very interesting. Sort of like now looking back and forth across all of the different devices. And yep, no drop frames. Okay, so I'm gonna keep my preview windows up there. Everything seems to be good. And still have like a minute or so left before it's official start time. I think what I can do is start getting everything ready. So let's bring up here. Let's go to GitHub. And learning Rust. Okay, so we're currently at given a list of integers, return a vector and return the mean, the average value, median when sorted, the value in a middle position, and mode, value that occurs most often. A hash map will be helpful here of the list. So this is the project that we're working on right now. We got really close to doing like the first version of this, and I sort of had some ideas of how we can like maybe break it out, not just do it in different functions. We actually, I think we still have some other things to do with it, but I think we'll get a lot farther today because we won't have quite as many technical errors. At least as long as this other computer doesn't hiccup or something. Let's see. Other things. If you're watching this stream, please feel free to say hi in the chat. I'm always happy to talk while we're learning here. And then on top of that, if you're watching the VODs on YouTube, feel free to leave a comment. Say hi, see if you're learning and what's going on. I do, before I dive into like continue with the project, I want to show off a project that a friend of the stream, Danny Fritz, sort of like made and sent to us, or sent to me. So desktop, he made a Pong in Rust. So let's see. So it's cargo run, I think, -p. So this is fully open source. We can go and I'll show where the repo is in case you want to take a look at the code. It did take me a little bit of time to get this working on Linux. It is working. He said it's guaranteed working on Windows though, and he doesn't have a binary set up for it. Okay, so here we go. We could, it's a full native window and we could even full screen this. It's W and S are the scan codes that are used for the left. Unfortunately, it's the numpad that's moving the right paddle, and I don't have a numpad on this keyboard, so I can't actually play against myself. But this is definitely Pong running in here. And if I remember correctly, Danny said that he was not using a library for this, but rather just using the pure, what is it, one of the GPU packages. Looks like, well, it might not even be in here. Oh, he does have, so ALSA is being used for sound, which I don't think I have sound set up for this computer right now, so not for this stream. But let's take a look at the code here. Basically, it looks like he has. If we take a look at the README, in Pong RS, which is this entire README here, it's a collection of different implementations of Pong in Rust. So we have the Pong library, which is just the logic for the Pong game itself, without the implementation details. And so this is where we can see, okay, here's our ball and how it's going to move around. And this, I mean, this seems pretty simple to actually see what's going on. We are using a library for Collided 2D. I don't think, yeah, he didn't implement that himself. And we're using vectors for the position and the velocity. So we're able to use vector math to be able to like add things together and then like send, you know, position where the ball is. That way we can say, okay, when we're bouncing, like when we initialize a ball, where it's going to be on the screen. We're using 32-bit floating point numbers. The R is going to be its size. So here's where we can like do all sort, like if we wanted to customize this, we could definitely come in here and potentially make another library that controls the computer player and then sort of implement that so we don't have to play against ourselves. Anyways, I'm going to put a link to this. Go find it. Actually remember that I had I'm just going to look at the remote. So get remote beep. There it is. Really? That should load up. Oh wait, I'm not. Why did you come in here? There we go. This will load up. Where's our Git Pong? Pong RS. So this is the URL for Pong. I'm gonna add it to the chat, and then also add it to the description in the YouTube archive. I also realized I'm not wearing my glasses, so. Okay, and with that, let's sort of move on to our own thing here. Okay, so we're currently on list of numbers, I believe, was what it was called. And so yeah, this is where we're getting to like the mean of the list is blah, the median, and the original vector. So right now we had been working through, we got through the mean of the list, and the next thing is get the median. So the first thing, what we were doing initially was we were sorting the list so that it wouldn't affect this original list. Because I think that's, like, this is a potential, like, this is an interesting thing is when we use this function get median and we pass it the list, should the list be changed or should the list stay exactly the same? And in this case, we're cloning it so that we don't change this list. It could be completely out of order, but we're still going to get the median. Now, we need the median, which is the center thing. And one thing that I'm not completely sure of is for like medians. So median of list, even number of elements. I'm just curious what the median means in this case. To find the median of the data should be arranged in order from least to greatest. If there is an even number of items in the dataset, then the median is found by taking the mean average of the two middlemost numbers. Okay, so that's interesting because I can actually use get mean here. Because if I have a vector of two things, I can get the average of that. I just screwed that up. Okay. So what I want here is to be able to get a slice of, well, okay, in this specific case, we know that it's going to be 3 because it's an odd. So let's figure out how to guarantee that we've got this. Right now, the list is this. We know that it's sorted. Maybe something that would be interesting is do a little bit of math here. So if we get the length, so let length equals sorted list dot ling. So if we have this, if we divide this by 2, what happens? Okay, let's try running this and see what we get. Cargo run. The list is now 2. So if we use this as like an index, 0, 1, 2, that's perfect. Now, if I put another element in here, so like 6, the list is now 3. So I wonder, and then if I do another one, the list is now still 3. So I think that what might be good is figuring out if the length is odd. So what options do we have here? I know like there's modulus in many languages, and I haven't actually looked, I don't think, to see if we have that here. If I say something like for modulus 2, the list is now 0. Okay, so that's that. And if I do for modulus 3, the list should be 1. Yes, okay, so it works the way that I was expecting it to work. So we have length, and then we have is odd. So that is even, we can set this equal to length modulus 2 is equal to 0. This should be a Boolean. The list is now false. 1, 2, 3, 4, 5, 6, 7. That's correct. And now it should be true. True. Perfect. Okay, so coming back to the original list, if it's odd, how can we find the middle number? So is it true that if I just divide by 2 and if it's middle, that's going to be the index that I want? It's possible. So in this case, if I divide by 2, then that's going to give me 2, right? So because we're talking about integers. So integer math is a little bit interesting because it throws away the decimal place. It will give me 2, which would be this position. So let's try this. I want to say, get the median here. So if even, we know that if it's odd, so if not is even, so we're sorting here. Okay, so if not is even, oh, I forgot. I'm not programming in JavaScript right now. Okay, so if not is even, then what do? I want to just return this list, which should be sorted list. I think I'm going to have to just do return sorted list of length divided by 2. Maybe missing the else clause, expected closing parentheses, found I32. Oh, do we have to have an else clause? Expected I32, found this. So in here we're going to have the opposite thing. If we're odd, so this is if we're odd. I don't like this. I'm going to change this to is odd equals not equal here. That way I can just do is odd. This can move down here. And you, okay. Now if we're 1, 2, 3, 4, 5. Wait a second. If we're odd, we do want you up here. Never mind. I had the logic weird in my mind and I was confusing myself. Okay, so if we're even, then we need to find the 2 middle numbers. So that's going to be interesting. If we make this even, so like that. So 1, 2, 3, 4, 5, 6. 6 divided by 2 is 3. So 0, 1, 2, 3. That's going to be this one, and it's going to be these two. So is it always going to be the case that is these two? So 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 4, 0, 1, 2, 3, 4. Yes, it is. It is going to be that one plus the one to the minus of it. So we're going to want to get a slice of those specific two, which is going to be sort of like the sort of middle. We can now do middle equals length divided by 2. And I can just put middle right here. I think I should do middle index. So I want to get a slice, and I cannot remember off the top of my head how to get the slice, but I'm going to try it first, and we'll see how good I do with this. Okay, so I want to say let sort of like the middle 2. Oh, we're going to set this equal to sorted list of middle index dot minus 1 dot middle index. And I want to print this out. So print, we're going to say, did we get a slice? And we'll call this middle 2. And I forgot a semicolon. That's what I forgot there. And of course, I need to actually return something. And I'm returning an I32, so I'm just going to say 33. Middle 2, the trait bound I32 standard marker sized is not satisfied. I32 does not have a constant size known at compile time. Okay. So it's not exactly the right way to do it because we don't know how big this is going to be. The trait bound I32 standard marker size is not satisfied. I32 does not have constant size known as compile time. The trait standard marker size is not implemented for I32. Okay, so sounds like that's not exactly the way to get the slice. So let's go back to vector slice rust. So I wonder if we're getting a vector here, if we're going to get a slice here. Nope, it doesn't look like the examples here, so let's find out. Slicing. A vector can be mutable, slices in a hand or read-only objects. To get a slice, use the ampersand. Aha, that's what it was. So, and I want to grab a slice of the two things. So read slice, this takes in the slice, ampersand that vector, so equals this one, read slice and pass in, well, I want not that, I want a small part of it. And I remember there's a way for me to go in and say, I want a very like only a certain piece of it. Okay, so I think this is telling me exactly that, although I could try the ampersand and then doing things inside of the square brackets. That might work too. Where are we? Okay. ampersand. Aha, there we go. So now that seems to be good. Let's save this and try running it. Did we get a slice? We got 4. So we really wanted to get between the two, like a slice of like the two numbers. And what was it? So it was, oh, we're not displaying out, but it was like 1, 2, 3, 4. So if our, do we have a length? Middle index minus 1. So whatever the middle index is, so 1, 2, 3, 4, 5, 6, 7, 8. So that would be 8 minus 1, that's 7. So 0, 1, 2, 3, 4, 5, 6, 7. Oh wait, no. 8 divided by half is 4. Minus 1 is 3. So 0, 1, 2, 3. So I wanted 2 to be on one side, and I got 4. And middle index is 4. Oh, but it won't be in this order because it'll be 1, 2, 3, 4. What's interesting to me is that it looks like we got just one thing, right? So if it's 0, 1, 2, 3, 4. So we got 4, which is a third index. So I think this is wrong. We want all the way until the next one. Do I need to do like a +1 to make sure that because I can't remember, is it inclusive or non-inclusive? Do we get a slice? 4 and 5. So I think that's what we wanted to do. Is now we have middle index +1, middle index -1 to make sure that we're getting the middle here. So now our middle 2 is correct. We now want to pass that into get mean. So let mean equals get mean, and we're going to pass it in the middle 2. Mismatch type, expected struct, standard vector, found a slice. So I think this would be better to convert this over to wanting a slice, right? So let's see what we can do with this. Okay, to get a slice, it's going to be just, so when we take it in, it's going to be the ampersand, square brackets, and then usize for whatever it is. Now forget mean. Well, okay, you didn't, I saved, but I don't think it updated its errors here. Oh, expected usize found I32. I could actually make these I32s because that's kind of what they are. All right, so that solved all these. I'm surprised that I didn't have to slice this one when handing it to get mean. Okay, so then we have the mean. So then what we want to do is, well, that's kind of what it is, isn't it? We return this. So we want to return mean. Mismatch types, expected I32. Oh, okay, so that's going to be interesting, is we want F32 for this one because it could be different. Well, we are passing mean on a slice of I32, and this is supposed to return an F32, I just need to say that this is going to be an F32, which of course means on this size, return a sorted list. We need to as F32 to cast it. Is odd, should have snake case, you're right. Right. Before I do that, I should select all of you. Okay. And then finally, now we can have print line get median. So let's try this out. So in a vector of 1, 2, 3, 4, 5, we know that it should be 3. So the median list is 3. If we add 6 and 7, it should be 4 now. And it is 4. And if we add an 8, then it should be these two that are averaged together. So 4 plus 5, it's actually easier for me to just get a calculator. So if we do 4 plus 5 and divide that by 2, that's going to be 4.5. So that's what we're hoping for here. The median of the list is 4. So I think it's hard to tell. Is that because it's not displaying? Is it the F32, like I was hoping that this would come in and actually create it as a, give it floating point numbers. But yeah, so if it's, the median list is just 4. Oh wait, I didn't save. 4.5. And the mean of this list is 4.52 now. So we had already sort of figured out that that was working. So perfect. Okay, so given that, the last thing is the mode, the value that occurs the most often. And once we get these, we're going to refactor through and sort of like decide what better way we can use data structures to like store this stuff. Okay, so print mode of the list is get mode, and here I want to hand it, oh, we are handing it a slice of the list, aren't we? Hand it a slice of the list. Get mode doesn't exist, obviously. We were about to fix that. So function get mode. This is going to take in the list, which is a slice of I32. And we're going to return, it's the number that occurs the most often. So this is going to be an I32. Okay, so the idea is that we're going to want to iterate through this list and create a data structure that will, for each one that's in there, like we could put the number as the key, right? So the idea is that we might have something that looks like this with one time and 2, 4 times. And then at the very end, we can just look through which one is higher and return that one. So what we want to do is, let's just first initialize, and this is where the hash map, I think, is where they're suggesting this will be good for it, because we can just set those as keys. but I think the first thing I want to do is iterate through this list. So I'm going to start with 4, and it's going to be number in list.iter, and I'm just going to print the line, and we're going to, that's print. I want print line. And we're going to say number. Now, of course, it's yelling at us because we're not actually returning a number, so I'm going to return number 1. And we should now get the entire list out. So there we go. It's in the same order. It's our list. So perfect. Now, what I want to do for this is we want to create a hash map. And I think the big thing that I remember is hash maps aren't actually aren't just available to us. They're not in a prelude. So we have to bring it in with use standard. Was it component? I can't remember off the top of my head. Let's go find it. So Rust hash standard collections hash map. And the way to sort of set this up is we bring in collections hash map, and now we're able to say hash map new, and then we can insert key and value. It's just yelling at us that we're not actually using it. So let's go ahead and initialize a new one. So let mute, this is going to be my numbers equals hash map new. So now we should be able to insert these into here. So instead of just printing these, there's also that thing where if it doesn't exist, set it to be 1, and if it does exist, increment it. So I vaguely remember it's not going to be a pure insert. It's okay. I think it's going to be an or insert. Yeah, because this returns a yeah. Then it returns a reference to that key, the value in the hash map. So this is what we want, or insert. Now does it have to take a string, or I think that we can just pass it a number as its, like an integer as its key, and it will be fine with that. It'll figure it out. Also, why are you yelling at me? Right. Okay. You'll figure it out. Okay. So we'll begin by I have to set this as mutable. I don't. Okay. So let the key or value, call this value, equals, maybe I'll call it count. Let count equals numbers dot, and then it's going to be the number itself. So number dot or insert 1. Now I can say, well, if count exists, or I probably want to do or insert 0, right? Because immediately after that, I'm going to increment its count. So the reference, we have to dereference it, count plus equals 1. Expected function found, oh, did I? There's stats, oh, dot entry, that's what it was. Okay, so we've got this sort of increments it for each one, but then we need to iterate through these and sort of finish that up. But before I do that, I want to actually print off this hash map, make sure that everything looks the way we want it to. So let's do a print line. We're gonna say hash map and numbers. Okay, so where are hash map? So like these are all one, of course, but it did go through and create all these. So if I come in and I say for our original one, instead of something like this, we have like 1, 1, 2, 3, 3, 3, 4, 5, 6. Then we should have a little bit more interesting of a hash map. So 6, 2, 3. There's 3 of 3s. There's 2 of 1s. Yes, that's perfect. That's exactly what we wanted. So just 1, 2, 3. Yeah, it can get a little bit hard to read because of like the commas here. I have to look at that, but it is doing exactly what we want to, because now we can iterate through this and find and just accumulate, get the smallest one. So because if I remember correctly, we can iterate through just as easily as everything else. So I can do 4, and it's going to be key. So it'd be number count in numbers dot iter. We're going to print, and in this case, it's going to be count iterating through the map. And I'm going to say number count. Number count. Okay, save that. And number 6. So yes, here's we have like 3, 3. So perfect. We're sort of understanding how this hash map is working, how we're able to iterate through it, get the keys and the values. So the next thing we want to do is create an actual accumulator for ourselves. So let's mute accumulator, which in this case I might just call this the result or the mode. How about that? So we're going to call this the mode. We're going to in here if the most, so just the one that has the most, right? So we can even initialize this equal to 0. Okay, so if the count, well, I think it might be a little bit more interesting than this. The mode, we might not want to do our accumulator as just the mode. It's more of, we want to find which one has the most count and then pass the key back in. So we need to like check this. If the count is higher, then the number is what we care about. And this might be a structure that we use, or it could be a tuple. That might be better. So if we say the mode is, in this case, it's going to be 0, 0. I'm going to move this right down to this block. So now I want to say, okay, this first one, yep, I'm not using it. That's fine. I'll be using it very shortly. I could say that this first one is going to be the number, and this one's going to be the count. Now, I could also use a structure that has like number and count actually defined in it as words, and that might be a little bit easier. I want to first try it with here and then maybe refactor it to a structure. So if the count is greater than this count, then the number becomes what this is, and the count becomes what this is. Now, what I have forgotten is accessing a tuple. Is that with dot? I think it's dot like 0 or 1 or 2. The easiest thing to do for that is just try it. So if I print, say, tuple, and I want mode dot 1, I want to put u as 1 and 2, 1 and 0. And I need a semicolon back here. Tuple 1. So yeah, the dot 1 is exactly sort of how to get like this one. It could be dot 0, dot 1. Okay, so with that's how to set it and retrieve it, now I can say if we're going to have the count, if the count is greater than this, right? So if mode dot 1 is, I kind of actually like to go the other way around in my mind. So if count is greater than mode dot 1, then what do I want to do? So we're greater than that one. I want to say mode dot 0 is going to be equal to number, and mode dot 1 is going to be equal to count. Mismatch types, expected reference, found integral variable. Okay, so it wants me to have a reference here. And the number, expected integral variable, found reference. Expected type, I think I shouldn't need to dereference this, right? Oh, it is a reference. I might have to dereference it. Expected type, integer, found type. Oh, it's still found. Consider dereferencing the borrow. Well, I already tried to dereference it. I already saved it. Interesting. Let's try getting a little bit more help here from this. Okay, so expected integral variable found reference to I32. Consider dereferencing the borrow with asterisk asterisk. That doesn't seem like it's going to work. Now, I could do a match, but I don't think that's what I really want to do. It feels interesting, like it's telling me to dereference. I bet if I do this, okay, so that just works. So apparently number is double referenced. Yeah, we can see it. It's double referenced, whereas that's just single. That's actually really interesting. I did not realize that it would double reference it like that. Okay, but this gives us the counts here. So then what I want to do is whatever we have here at the mode is going to be it. So now we can return mode.0. And that will give us the highest number of occurring ones, which I believe in this one is 3. The mode of the list is 3. And if we add like a bunch of 6s, now it should be 6. Yes, perfect. So we got everything that we want to have. And with that, I think that's like technically we can claim it's done, but let's think about refactoring this. And I'm willing to take like, the rest of today, this morning, and also, tomorrow and however long to sort of like make sure that we're doing this in the more appropriate Rust way. I saw my screen flash with like potentially losing the screen, but it seems to be back, so that's good. Okay, so in this one, our list is fine to have this. What I want to do, let's go back to one that's known. 1, 2, 3, 4, 5. The regional vector is this. That's fine. So we may switch to actually fully resorting it. So in that case, I want to also reverse this. So 5, 4, 1. Okay, so let's think about structures that we can use. We could use an enum for the list itself, and then put implementations of get mean, get median, and get mode on the enum itself. And that might help out a lot, because then we can like, these aren't just separate now, they're sort of like including the entire thing. So an enum is fine, and like a structure seems a bit overkill. I think an enum, so we can like basically say this is a list of things. Let's do it. Let's go back to the documentation. Specifically, we go back to the book and remind ourselves about enums. And I think that was here, chapter 6, defining enum. So it's just enum name of the thing. So we're going to say enum, what is this going to be? I think it's just going to be list numbers. Oh, and we want to do capitalization because we're going to instantiate a new one off of it. So numbers, and it's really just going to be a vector, and I think we can call this, what would we say? Because it would be a custom type, so we just sort of name this as the custom type that it is. So it is my list vector. I think maybe this would be better as list of numbers, and then we'll just have numbers. You're yelling at me because you're not used, right? Numbers should have camel case, such as numbers. I don't agree with that camel case, because I don't think that actually is camel case. I think that's Pascal case. Okay, so we have this. We want to now create this as a vector here. So instead of just like pure vector, we want to put that inside of an enum. So Let's remind ourselves how to do that. So this is how to create specifically that thing. Oh, I think structure. How do we put the data inside of the enum? Oh, that's what it is. So it takes a vector. So numbers, was it colon colon? No, numbers parentheses. Is it vec or vector? I think it's vec of I32. Then we have this, and we're going to create this from the enum, say which one we're going to do, and then pass in the data. So let list equals so my list here, it's going to be list of numbers, and we're going to pass it in a vec of 5, 4, 3, 2, 1. Okay, now of course this causes problems because nothing is expecting this custom data type of list of numbers. So now we're going to have to like change everything around to pass in this specific thing. So for example, get mean here doesn't want a list, doesn't want a vector. It wants, well, sorry, it doesn't want a list of numbers. It wants a vector. But we're not going to be doing that. Instead of get mean like this, we're going to have print line the mean of the list is, and it's going to be the list dot get, or just mean. Of course, it's not implemented on here. Okay, so what I want to do here is now add an start implementing. So we're going to implement list of numbers and add our code in here. So this is going to be a function mean. This takes in, what was it, a reference to self. I don't think we need anything else. And we're going to return what? An F32. Which of course this is saying like, hey, you can't do that. You're not responding with an F32. If I do something like 32.0 as its return value, this should just get us our mean and should just work. The mean list is 32. Perfect. So let's actually now implement our get mean inside of here. So the idea was we do have self, and if we take a look at what self is, we should see that it's really just this list, right? I believe we can print this out, right? Can we print line self like that? It's a macro. List numbers doesn't implement. Oh, standard format debug. Okay, so we need to add in this derive debug into list of numbers. So hash derive debug. Can't remember. Do we need semicolon for that? expected item after attributes. Really? Hold on, I want to look at this again. Okay, so add derived debug or manually implement standard format debug. I guess we could manually implement that too. I don't think we've, yeah, so every once in a while I saw the screen just sort of like lose itself, and that's a bit jarring. So I don't know, I may have to like figure out what's going on with that. Add derived debug. That looks like exactly the same thing that I have. So hash, derive. Oh, debug with a capital D. Like that. Okay, so let's take a look at this. Let's make sure that our self is exactly what we think it is. Cargo run, and so it's type numbers, and we see this. It's our 54321. Perfect, exactly what we wanted. And I just realized that it is almost 8 o'clock by about like 15 seconds. So I'm gonna go ahead and start saving all of these things so I can send them on up to GitHub. Let me do that first. Let's see, finished basic version, now refactoring b and enum. Okay, so we got that, and I also want to update not chapter 8, Vim the README. So here we've got this, but I want to set this to be refactor. I kind of want to bold this. Okay, so we're refactoring this. Did that not get updated in here? Git add the README. I was kind of hoping that that code would catch it, or GitHub, so I can do that, but that's fine. Git commit -m updated where we are at, and we'll push this on up to GitHub. Let me share with you the link of where we can find this. It's on GitHub. At Learning Rust. The README is right in here, and then all of our work is in chapter 8, in specifically the list of numbers. So if you want to follow along, this is where all of our code is. If you see the previous videos, the code for here is as well, or links to where other code repos are sitting. I am exporting these videos to YouTube, so if you're going to watch after the fact, or you just tuned in and you've missed some of it, you want to go back and see the other ones, I have a link to YouTube down below in the description for the channel. And I also have a link to my Twitter, and I tweet out usually the night before, or sometime before I stream, when the next official stream is going to be. If you're liking what you see and you want to get notified, please follow the channel, and also let me know in send me a message on Twitter, send me a message on YouTube, or chat here on Twitch, because they're turning off the messaging service for everybody. Just let me know. Are you enjoying this? Are you learning Rust too? Are you following along with these videos? I would love to find out more about that. And with that, I think it's time for me to have the rest of my day. So thanks for stopping by and watching, and I'll see you all next time.